দেখো এখানে আমরা যেটা করব, we'll discuss about the detergents and its function, how we can clean our clothes by the colloidal particles. And this type of colloidal particles, it will be this contains two parts, hydrophilic and hydrophobic parts. Okay. So mechanism of the formation of micelle is, let us take the example of soap solution. Soap solution, it contains two parts. One is R part, R means hydrocarbon part, and there is another part that is acid salt part. There was acid, it will be salt. It contains Na plus or K plus, etc. Soap is the sodium or potassium salt of higher fatty acid and may be represented as RCOONA. Okay, R is a bigger part of the hydrocarbon. It contains at least 17 carbon. Sodium, this is also known as sodium stearate, which is the major component of the many bar soaps. So there is a carbon সংখ্যা 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17. So minimum 17 carbon is there in hydrophobic part, and this is the hydrophilic part. Okay, when dissolved in it water, it dissociates into RCOO minus and Na plus ions, like this. And hydrogen and carbon containing part of this soap is known as hydrophobic, or it is also non-polar part, which is the tail of the soap or detergent. And this is actually hydrophilic part, which is polar or ionic part, which is also known as the head of the soap. That is non-polar part, water heating part. So it is stays from the water, and it is love water. So water loving part. So it is remains attached to the water. For this reason, the foam will be formed, or leather will be formed. Okay. Shade, if it contains water, then hydrophobic part, it is tail, and hydrophilic part, it is head. The head always try to swimming in the water, and the tail always try to escape from the water. Yes, because this tail is hydrophobic, so it is try to escape from the water, and it will be aggregate to the dirt particle, because dirt particle is hydrophobic part. In our clothes or anything contains dirt particles, then dirt particles are hydrophobic part, and soap also contains hydrophobic parts. So this is the white portion. This white portion is actually dirt particle. So dirt particles always bind with the hydrophobic part of the soap. So hydrocarbon chains point towards the center of the sphere. So this sphere contains this the white portion. This white portion is actually dirt particle, and it will aggregate. Okay, and will form a micelle which will be in large size, then this dirt particle will remove from our dress. And this negative part is the COO minus ion part remains outside of the sphere. The aggregate thus formed is known as ionic micelle. Similarly, in case of the detergent like SO3 minus Na plus, the polar groups is SO3 minus along with long hydrocarbon chain, and hence it has also the same mechanism of micelle formation. Cleaning action of soaps. So there are dirty particles. It may contain grease stains. This is hydrophobic part. All that part are hydrophobic parts. It may be oils, it may be grease, mobiles, etc. Then cleansing action of soaps, how it can act, because soaps contains tail or hydrophobic part. This hydrophobic part aggregate with this type of dirty particle and it will form micelle, and this micelle will be heavier and it will be removed from the cloth. So, do you want to know how does soap work on removing grease stains? The cleaning action of soap is due to the fact that soap molecules form a micelle around the oil droplet. So, this is the soap. Hydrophilic part is negative part and this is hydrophobic part. This hydrophilic part loves water, so it will remain in water, and hydrophobic part love actually dirt particle, or it is water hating particle. Okay, so it hates water, so it will attach to grease, because grease is dirt particle and it's hydrophobic. So the tail will aggregate with the grease and then it will be from a heavier particle and it will be removed from the stains. So there is a micelle. This micelle will remove from the dress or our hands and or in our from our body. Clear? The soap helps in the emulsification and washing away oils and fats. So cleaning action of soap is due to formation of micelle. Yes. Formation of bubble. No. Presence of hydrophilic part only. Presence of hydrophobic part only. So formation of micelle. Preparation of colloids. There are so many types of colloids and we can prepare it. We already discussed about Bredick arch method, step down method, step up methods, etc. So first one is chemical method. Colloid solution can be prepared by chemical reaction leading to the formation of molecules by double decomposition, oxidation, reduction or hydrolysis. Double decomposition, a sol of arsenic sulfide is produced by passing hydrogen sulfide into a cold solution of arsenous oxide. Ab plus Cd, double decomposition, then whatever Ad and Bc. Okay. So this is double decomposition or double displacement reaction is also. Arsenic oxide, hydrogen sulfide, then it will be arsenate sulfide and water. Okay. So this is sol. This arsenic sulfide is in colloidal particle size. By oxidation, oxidation means oxygen addition. Then a sol of sulfur is produced by passing hydrogen sulfide into a solution of sulfur dioxide. So sulfur dioxide plus H2S, the oxidation takes place. Okay, then only sulfur is there. This is sulfur sol or colloidal system. So sulfur is oxidized by sulfur dioxide. Oxidation state of sulfur in H2S is -2, and for only sulfur it will be 0. By reduction, reduction is gain of electron or decrease in the oxidation number or addition of hydrogen. Gold sol can be obtained by treating dilute solution of gold chloride with methanol or formaldehyde. That's mean AuCl3, where the oxidation of gold is +3, then it will be reduced to gold. So this reduction, there is a +3 oxidation state, there is a 0 oxidation state. Yes. So gain of electron, this is reduction. So by the reduction, we can form colloidal salt or gold salt. By hydrolysis, hydrolysis usually means the breaking of the chemical bonds by addition of water. That's why addition of water actually. Ferric chloride, if we add water in presence of something, that's mean it may be some NOS also. It will form ferric hydroxide. This is also sol. This is ferric hydroxide. This is also sol. So oxidation state is not changed here. So this is not oxidation reduction reaction. But it is actually, what is this? This is hydroxide. Oxidation of iron does not change. Oxidation state does not change. Okay. So this reduction word, it is wrong word here. Okay. It is not reduction. It is actually sodium hydroxide. In presence of sodium hydroxide, it will form ferric hydroxide. This is also sol, and this is not oxidation reduction reaction. It is only addition of water to a compounds. Now red sol of ferric hydroxide can be obtained by hydrolysis, not reduction. Okay, it is
hydrolysis.
yes. Sulfur sol can be obtained by reduction. Yes. Sulfur sol, this is reduction. Sulfur sol from H2S, you can obtain its reduction. So this is, I mistake it. Okay. Preparation of colloids too. This is preparation of colloids. This is electrical disintegration or Bedik's arc method. To already tell you a story that I used two blades for heating water like a heater, and one day it was melted by arc. Okay, and that was the colloidal solution. Now, by Bedick arc method, this process involves dispersion as well as condensation. We know about the dispersion. A dispersion is a system in which particles are dispersed in a continuous space of a different composition or state. And condensation is the change of the physical state of matter from gas phase into liquid phase. Okay. Water vapor condenses into a liquid. Colloidal solution of metals such as gold. This is gold salt. Silver salt or platinum salt. This type of costly metal salt we use in our experiment, okay, for different experiment, because this type of salt we can reuse and we can reform it. Okay. Bedick arc method, there is a two electrode, one is positive and one is negative. If just we touch to each other, then there will be arc and it will be melt out, because there will be huge heat generated. Electrodes of metal, dispersed medium, this is ice cold water, because there will be huge heat after arc. In this method, electric arc struck between electrodes of the metal immersed in the dispersion medium. When electricity is applied, the electrode produce intense heat due to the collision. Okay. If they touch to each other, then intense heat will be produced by this two electrode and it will be made out. Just touch it. Okay. Due to the intense heat, electrodes of metal vaporizes, and by this cold water it will be cooled down and it will form colloids. So vaporized metal then condense to form particle of colloid cells. Peptidization. The method, another method for the preparation of colloids is peptidization. It may be defined as the process of converting a precipitate into colloidal salt by shaking it with dispersed medium in presence of small amount of the electrolyte. Like freshly prepared colloids, if we shake it with the water or dispersion medium, then again this precipitate will form, or it will be dispersed in the dispersion medium and it will form colloids. The electrolyte used for this purpose is called peptidizing agent. So what is the peptidizing agent and what is electrolyte and peptidization? Okay. This method is applied generally to convert freshly prepared precipitate into colloidal solution. So there is a stable precipitate. Then we use some electrolyte and it will be shake. So during peptidization, the precipitate absorbs one of the ions of the electrolyte on its surface. Then this causes development of the positive or negative charge on the precipitate, which ultimately break off into smaller particles of the size of the colloids. So there is a size of the colloid particle. So electrical disintegration of or Vedic arcs method involves dispersion, condensation, none of these. Okay, so dispersion, condensation, let's in both. The process of converting precipitate into colloidal sol is called peptidization. And thank you. Okay, so